In previous lessons, we've drawn and painted all sorts of things on the screen. Some of the pictures were built up by drawing one thing after another directly onto the screen every time we wanted to update the display. There is another approach, and there are places where drawing composite pictures in memory really comes in handy. For one thing, if the picture is complex and takes time and resources to render, you only have to do it once and then you can put it on display whenever you like. This is the Draw Memory Canvas class. It's a canvas that creates an empty memory resident image object, then paints some things into it. The image object is then painted to the window of the canvas so we can see what it looks like. We're going to be loading an image from a file, so we'll need an image loader object. Of course, we could just copy the code from the image loader class and put it in this class, but you can see how convenient it is to have stuff that you can use over and over again. The call to load image from file loads the graphics file and stores its image here as an image object. Using the height and width of the loaded image, the height and width of the window is set. That's all that's done in the constructor. The rest of the action is in the paint method. At the top of the paint method, there is a check to determine whether the reference named image is null. If this image reference has not been initialized by the paint method, it will be null because Java always initializes all variables and all references are automatically initialized to null. The call to the createImage method creates an empty memory resident image object. The createImage method is part of the component class, and the canvas class extends the component class, so it inherits this method. Once the window has been realized, and we know it has been realized now because it has come time to paint stuff on it, you can create all the image objects you need. In later lessons, we'll be looking into why you might want to create image objects over and over again. Now, just like a window being displayed, every image object in memory can produce a graphics object that you can use to draw to it. This means that every method used to draw into a window is also available to draw into an image in memory. Well, there is a special limitation. This is true only of empty image objects that you create the way this one was created. The image object that was created by loading the file won't let you have a graphics object, but that's okay. All we need is the empty one to do everything we need to do. Using this new graphics object that we got from the memory resident image object, we call the drawImage method to draw the loaded graphics image file into it. They're exactly the same size because that's the way we created the image. But we don't stop with that. Here we create a new font and set it into the graphics object of the image and draw a string of characters on top of the blue marble image that we've already painted there. Now all of this will only happen once. Once this block of code has executed, the reference will continue to hold the address of our memory resident picture, so this entire block of code will be skipped from now on whenever paint is called. The actual rendering to the window is made with a call to drawImage to place a copy of our memory resident image on display. After the first time through, if the paint method is ever called again, this is the only code that is executed inside the method. Several things can cause the paint method to be called again. If the window becomes obscured and then is made to reappear, the paint method is called to make it display itself. If the window is minimized and then pops back up, the paint method is called again. Whenever the size of the window is changed to either larger or to smaller, the paint method is called again, and it may or may not adjust itself to this new size. This program does not have any size adjustments, but we'll be doing that very thing in a future lesson.